We need to talk about how we deal with really large or really small numbers in science. And to help us with that, I've given us two examples here of two examples, one number that's really, really large, that's Avogadro's number, and the other one's the radius of a proton, which is a really, really, really small number when measured in meters. It really becomes burdensome to deal with all of these zeros all the time. So we have this thing called scientific notation. And this is just how we get numbers into scientific notation and also how we deal with them once they're there. I didn't put commas in here, but if I would put the commas in here, it does make it easier for us to count up these zeros. But it still is really easy for us to get mixed up about this because you can see we have 3, 6, 9, 12, 15, 18, 21 zeros there. Now, one of the keys to understanding this is realizing that I could also write this number this way. 6.02 times 10 times 10 times 10. Well, you probably remember from math class that each one of these zeros is a placeholder that represents a factor of 10, and so we could just keep right on going. I'm not going to do them all, but how many times would we have to multiply this by 10? Well, if we think about the decimal point being right here after the 6, okay, well, how many decimal places do we end up moving it? We end up moving it 23. So however many times this would be, I would be multiplying by 10 23 times. Well, we have a way in math by using an exponent of denoting this. And instead of putting 10 times 10 times 10, 23 times, we put 10 to the 23rd power. And this is Avogadro's number written in scientific notation. And by the way, this is the number of particles or atoms. I'll just say units. Units could be molecules, number of units in what we call a mole. Mole's a counting unit. It's like saying there's 12 of something in a dozen, 12 eggs in a dozen, 12 donuts in a dozen. Well, there's 6.02 times 10 to the 23rd, whatever, atoms in a mole. So that helps us with that size, which is a really, really large number. But we also have to deal with really, really small numbers sometimes. Here's the radius of a proton. Protons are really, really small. They're in the nucleus of the atom, and it's just phenomenally small. Let's just count up these zeros. We don't put commas here, but let me just put some markings here that'll help us count by threes. So we have 3, 6, 9, 12, 13, 14 zeros here. Now, if we were going to write this in scientific notation, we would be putting 8.7668. But this number is really small. And so what we would be doing is I'm going to write this as a fraction, we would be dividing by 10 we would be dividing by 10 multiple times. Well, how many times will we have to divide it by 10? Just to make sure you understand what I'm saying, you know that 8.7668 divided by 10 one time is going to move that decimal point one place to the left. And so what we're doing here now is we're dividing by 10 multiple times. So how often would we have to divide by 10? Well, here's 3, 6, 9, 12, 13, 14, and to put it here, that would be, we'd be moving at 15 decimal places. So we would be dividing by 10 15 times. Well, mathematically, we can look at it this way. Take that number, and this is 10 to the 15th power. Now, if you remember your laws of exponents, but when you bring an exponent like this, when you bring a factor like this out of the denominator up into the numerator, what you do is you change the sign on the exponent. So this is 8.7668 times 10 to the negative 15th meters. Now, I want to try to get us to understand how we use these numbers. So for example, in our first case, thinking about a mole being 6.023. So here's a question for you. How many atoms, and it wouldn't have to be atoms, you could substitute in there molecules, ions, are in 5.5 moles of hydrogen? Well, so we know that 1 mole of hydrogen is going to be 6.02 times 10 to the 23rd power. That's 1 mole. We have 5.5 moles of hydrogen. So we're going to have to multiply this times 5.5. On your calculator, and I don't have a calculator here to pull up on my screen, you have a button. Sometimes it's a second function. Not always, but sometimes you have to press the second key to get this key, which allows you to punch in a number like this into your calculator. But let me just show you what's going on here. What happens here is it's like taking 6.02 times the 5.5 times the 10 to the 23rd power. So if we take 6.02 times 5.5, that's 33.11 times 10 to the 23rd. Now we have a rule about scientific notation that we should only have 1 unit to the left of the decimal point, so we actually should take this and make it 3.311 times 10 to the 24th. Now you see I moved that decimal point 1 place over, so I had to increase the exponent from 23 to 24. Well, what about numbers that are really, really small? Because we had this number up here, the size of a proton. We do the same kind of thing. So we could ask the question, this is the radius of a proton. So how wide would 3,310 protons be if placed? Now you could never place protons this way, placed side by side, straight line. So we just line them up. You're lining up 3,000. Well, so you have to take this number, this is 8.7, 668 times 10 to the negative 15th meters, and you're placing these protons side by side. So you're going to have to multiply it by that. And then the other thing we're going to have to do, a little tricky, I worked this in here, I didn't mean to, but this is the radius. Remember, in a circle, the radius is 1/2 of the diameter. So we're going to have to multiply this by 2 as well. Really what we have here is 8.7668 times 3,310 times 10 to the negative 15th. Well, so what you do is you work this out, and you can do this with a simple calculator. 8.7668 times the 3,310 times the 2 is 58,036. Now, times 10 to the negative 15. I'm not going to confuse you or make this a lesson about significant digits. Some of you know that because of significant digits, this should really be 58,040, but that's a different lesson. But we do want to move this decimal point. So this becomes 5.8036 times 10, and I move the decimal point from this position. I'm moving it to the left 1, 2, 3, 4 places, and so now I need to do something with this exponent of negative 15. And so just like up above, when I move the decimal point to the left, I added value to the exponent. So this becomes, I'll just break it out this way for you, negative 15 plus, I moved it 1, 2, 3, 4 places, plus 4. So it's really 5.8036 times 10, and negative 15 plus 4 is negative 11 meters. So it's still this really, really small. These protons are really, really small. And in fact, we don't exactly agree on how wide they really are. But this is just an example of working with these numbers that are in scientific notation and multiplying them and paying attention to your answer then in terms of showing it in scientific notation and dealing with these exponents. This can seem a little bothersome at first if you're not used to dealing with scientific notation, but the reason we do it, one of the reasons, there's a couple reasons we do it, but one of the reasons we do it is because these really, really big numbers like this and these really, really small numbers like this are just really, really cumbersome to work with, and this actually helps us out and makes it easier and helps us to make fewer mistakes.